Welcome to this presentation. My name is Mahery and I want to present you an accurate identification method of exons using an Antinoch fractional filter. As an outline, we start with an introduction, then a brief presentation of genomic signal processing, followed by the fractional digital filter, our method, an application test, and the conclusion. Genomics is an important part in the fields of biotechnology because it studies directly the DNA, which is the basis molecule for the living organism. We also know that a DNA sequence can be divided into two regions, the intron and the exon. The exon, which is called the coding region because it is the responsible of transmission of genes and the protein production. Since a long time, scientists know that genes can be the origin of genetic diseases, but also the solution can be found in themselves. Knowing that, scientists from different fields try to find new methods and approaches in DNA analyzing. Then a new discipline was born, the genomic signal processing. Genomic signal processing is the analysis of DNA sequences using the digital signal processing techniques. Generally, the GSP follows 5 steps. The first is the collect of the DNA sequence, then the step of numerization, followed by the application of digital signal processing techniques, the classification step, and the result. In the most techniques, the GSP methods exploits the property period-free periodicity, which states that in the spectrum of the DNA sequence, there is a peak at the frequency f equal n above 3, where n is the length of that sequence. And that peak only appears in the exon region, the coding region. For our work, we try to apply a digital fractional filter to predict the exon. This filter has advantageous features such as the high amplitude gain, a narrow bandpass frequency, and a better stop band attenuation. As an application, we took a DNA sequence from the NCBI database and compared our method to two basic methods in genomic signal processing, which are the Fourier method based on the direct Fourier transform and the method based on digital antinotch filters. Indeed, these two methods are the base of other methods used in GSP. The visual result shows that the graph below, which is our fractional filter, can better highlight the presence of the two exons in the sequence compared to the other two methods. In addition, our result has a higher amplitude of the signals due to the gain of the fractional filter. To sum up, in this work, we use a fractional digital filter in the prediction of exons by adjusting its parameters such as high amplitude, narrow bandpass, a high attenuation stop band. We were able to extract the period-free periodicity property and detect the coding region in the DNA sequence. However, further studies are underway to evaluate the performance of this fractional filter in order to work with a wide range of DNA sequences and to compare its performance to more recent approaches in this topic. This is the end of this presentation. Thank you for your attention.